I'll probably get going now. So thanks everyone for joining. If there's any questions as I go through, please pop them in the chat and I'll do my best to answer them. And we've just got an agenda here. So I'm going to cover what are security baselines very briefly. I think most people will know what a security baseline is. What is OpenSCAP? What is the SCAP security guide? How to automate security hardening, and go through a quick demo. So I'm going to try and fly through a few slides pretty quickly and focus on a demo after that. So just a quick shameless plug of the company I work for, Advent One. So essentially, we help our clients on-prem and in the cloud to automate, uplift their security posture, a variety of other things that are listed here, and we'll also have a suite of managed service as a managed service provider. So how we use Runecast. So I did talk last year a little bit about how we use Runecast, and it was more sort of focused around automation with Ansible on VMware. This year is more about security. So we use Runecast internally as a managed service provider and for clients that we don't manage to help apply best practices, simulate upgrades, apply benchmarks across VMware and in the public cloud. And it helps us with our ISMS compliance as well. We sort of have that linked into our monitoring tools, our metric system. We use Ansible Tower internally to automate a lot of our environments. And we have a bunch of security services as well. And Runecast forms an important part of as what we do in IT operations as a managed service provider. So what is a security baseline? I think most people, I'm sure, are well and truly familiar, but just to set the context of what we're talking about, obviously it's a set of security objectives to be met. It's prescriptive guidance for establishing a secure configuration of an environment. So in the case of Runecast, that could be VMware or the public cloud. In what we're going to talk about here is really more around hardening Linux. It's focused on the technical implementation of technical controls. It's very detailed. There's hundreds of controls, which we'll look at today. There are multiple scanning tools available, and it is an excellent candidate for automation to apply and continuously apply a security baseline. So what is OpenSCAP? So SCAP is the Security Content Automation Protocol. SCAP is a standardized compliance checking solution. It's a line of specifications maintained by NIST for maintaining security of IT systems. And OpenSCAP is the open source implementation. So if you go to openscap.org, I've got a screen grab of the homepage here. There are a number of components that are provided as part of OpenSCAP. What we're going to focus on today is the SCAP security guide. However, there's a SCAP workbench, so a GUI for scanning and doing tailoring files and that sort of stuff. But basically, baseline compliance is what we're going to talk about today. So some fun acronyms. I'm not going to read all of these out, but as we go through, I'll do a demo after this, and these sort of acronyms are going to pop up in different areas, so it's probably worth touching on them. So XCCDF is an XML format for security checklists and policies. OVAL defines a secure state of objects, so configuration files, permissions, etc. CVEs, which I'm sure everyone's heard, is a reference dictionary for publicly known security vulnerabilities and exposures. And CCE, which we'll also see a bit of in this, is unique entries to configuration guidance statements and configuration controls. So if there's a setting you need to have switched on or something you need to do as part of a security baseline, it'll have a CCE typically attached to it. So what is the SCAP security guide? So I've sort of highlighted the diagram on the homepage of the openscap.org. This is the component we're talking about. So again, it's a single package to install. It translates security guidance into a machine-readable format. It provides automated policy scanning, reporting, and remediation, which is really the key thing we're going to look at here. All major Linux distros are supported, and there's multiple security baselines and standards supported. So CIS, HIPAA, PCI, and the ASD Essential 8. I'm Australian, as you may have noticed, and ASD Essential 8 is the Australian Signals Directorate. So the good thing where this goes sort of hand in hand with Runecast is Runecast can provide similar hardening standards to VMware in the cloud, and this can sort of match up from an operating system perspective. So the good news with all of the remediation is that there is Ansible integration. So effectively, if you do a scan and it's time to remediate, it'll generate for you an Ansible playbook to go and fix it. And that's going to be true across multiple security profiles. There are other ways you can implement this. You can have it generate scripts with Bash. You can have it built into to Anaconda, so to get kicked in when a system's built. But we're going to look at Ansible automation today. So the hardening process, and I want to sort of highlight the commands here so that there's a record of them when I go through the demo. But the first step is to install Ansible and the SCAP security guide package using a Fedora-based distro for this, but it'd be, if the distro of your choice is Debian-based or SUSE, you obviously use their package manager. We can have a look at what profiles do we have. So we can look at the SCAP content file. We can specify a particular profile. So in this case, it may be sys, and we can go and look at specifically what is the security profile or baseline that's going to be applied. We can scan the system. So we're going to essentially produce a results XML file and a report HTML that we can review to see what rules we passed and what rules we didn't. We can then generate an Ansible playbook to fix the system, which is quite a powerful thing to be able to do. If there's a lot of fixes that need to be applied and you want to make sure that they're applied, obviously generating an Ansible playbook is the way to go. And then you can run that playbook to remediate your system. I'll just check the chat if there's any questions. So there's no question there, but I'm happy to answer anything in the chat. And there's also the Picard approach, which is to basically make it so. So as part of what you might have a golden image build or something like that, where you might just say apply all of the rules at once to make sure that they're all applied. So you may have, like I said, a process where you bake golden images, and this would be something that you may want to do as part of that build process. The other thing we mentioned earlier was CVEs. So how do we know if we've got some package issues, so patching that needs to be done? So you can run DNF update info, and that'll give you a list of any security notices and any packages that you need to be aware of. What we really want to be able to do is download security advisories. So Red Hat provide this, so you can download those to your Linux system and produce a scan against those to be able to see, well, specifically what CVEs am I exposed to, so that you can go and scan again post-patching to be able to make sure that they've all been fixed. With all of these security benchmarks and so on, it is important to recognize that your mileage may vary. So you may not want to apply all of these controls, or there might be a control that breaks something in your application. So you can use tags to be able to effectively skip rules that you don't want to apply. So you can see an example on the right-hand side where there's a whole bunch that have been tagged, and they're also tagged with whether or not they need a reboot, whether or not there's disruption, and also the CCE number, which we talked about earlier. Obviously, test it before you're putting it in production, which I'm sure goes without saying. And ideally, you'd want to run your own configuration management afterwards. So an example of something that this does is sets a nasty US government message of the day, and you might want to replace that with your corporate message of the day or something of that nature, and have all of your software and everything else deployed afterwards. And ideally, you could bake this into your SOE or your gold images. So what are the benefits of doing this? So obviously, to mature your security posture, verify the implementation of controls, have a simple method of implementing an industry standard security baseline. So not one where you've rolled your own, where there are several security baselines depending on what industry you're in, the one that's most applicable to you. You can easily report on and remediate drift. It's a simple process to be included in your image build. It can be extended to scan container images as well as virtual machines, which is probably out of the scope of the 30 minutes I've got now. And obviously, bringing it together with Runecast can jointly secure your environment by both applying security baselines and best practices to your VMware environment and public cloud, as well as being able to harden your operating systems. So just before I jump into the demo, what would this look like as a production implementation? So this is how we do it. So we have a workflow that kicks off every week where we create a new virtual machine. We use Red Hat Satellite to kickstart and install Linux. We create an Ansible service account, which is going to be used for configuration management later, and inject the key. We apply the sys hardening exactly as we've described in this presentation. Then we shut it down and converted it to a template. So it's really handy to be able to do that, to make sure that every time a new system is deployed, it's from a system that's already patched, already hardened, and it's not being built by hand and it's fragile, or what happens if a new version of the operating system comes out? You don't really need to worry about it that much. And then we'll obviously have our VM creation workflow. So we basically, tool of choice for us, it's Ansible, could be Terraform, manual, whatever. Clone the virtual machine template. We register it into Satellite in the case of RHEL. We call back to our configuration management system to say, hey, I'm a new VM, come and perform configuration management on me. And then we're done. And a new machine that's been hardened, built properly, it's all patched and ready to go, is provisioned really quickly. It isn't limited to VMware. So an example of how we'll do it on Azure. So we'd have the same process kick in. We create a new instance in Azure from a Red Hat cloud image, or the image of your choice. We inject our Azure custom data, which is effectively cloud init. We create our Ansible service account and inject the key, perform the sys hardening, and then shut down the machine, create an image of it, and create an image gallery definition and publish that version so that we can then deploy that image gallery in Azure, so that image gallery version in Azure later. So the provisioning workflow, we basically create a new cloud instance from the image gallery. We inject custom data to basically tell it to do the registration to Satellite, and same as what we did in VMware, call back to Ansible Tower and say, hey, do a dynamic inventory update and come and perform configuration management on me. So just to give you a sense of how it would work in production as opposed to the technical steps to get this done. So unless there's any questions, I'm just looking in the chat, there doesn't seem to be any. I'll provide a quick demo of how all of this works. So the first thing we're going to do is SSH into our Linux virtual machine. So I've provisioned one earlier, and you'll notice there's a nasty US government message of the day that you may want to hang on to if you work for the US government, or replace it with something else. So this is the same as the steps I had in the slides, which I'm sure will be made available afterwards. We want to make sure we've got, we'll get to switch to roots. We've got the packages installed, so Ansible and the SCAP security guide. So we'll just wait for a moment for those to install. The next thing we want to have a look at is what profiles do we have. So we can run this command, and it will, in this profile, we've got a whole raft of them here. So there's the ASD Essential 8, HIPAA, we've got sys, D's a STIG, and PCI DSS. And we can go and have a look specifically at a profile by running this command. So you can see we've got the profile sys mentioned here. Apologies if you can hear my son playing basketball inside. So we can see we're using the sys benchmark, and that'll be the server one that we're going to use. So we'll now go ahead and scan the system. So I'll just paste the command in here. So what this is going to do is use sys as the profile. It'll drop a results file in my home directory. It'll generate a HTML report and put that in our home directory as well. So it does take a couple of minutes for this scan to finish. So I'll just give you an example of what the report looks like. I'll just double check the chat. So this is a OpenSCAP report. Brian's having trouble seeing my screen. Is anyone else having trouble seeing my screen? just drop us in the chat and let us know if you can. I think, yeah, so Kev has said to expand the window to full screen. Thanks, Ryan and others. So this is what the report file looks like. So we can see there are 133 rules passed and 130 failed. And this will basically step through all of the rules that we didn't pass. And for a bunch of these, which is really useful, is I'll try and find a good one. This will do. It'll actually give us a remediation shell script, Ansible snippet. So we can click here, and when it generates the fix, this is the Ansible task that will be generated as part of that. So that can be really handy. So you could go through every single one of these and work through the commands or the Ansible playbook to go and do it. Or you could generate an Ansible playbook to fix it, which is what we're currently working through. So it's this is actually built using the same, this is in systems, an example in Azure, which is built off a hardened gallery image. So this is going to finish pretty quickly because it's going to pass them all. And we'll go and have a look at, once it's done the scan, we'll go and generate an Ansible playbook to provide any fixes. And I suspect it's going to probably generate one to do nothing, or it might generate the one that does the whole thing. So we'll just have a quick look. But should be almost there. I'll just check the chat. Oh, Brian, you good. Thanks, mate. So this should be finished in a sec, and hopefully then we can have a look at the playbook. So the other option was that I had in my slides earlier was to be able to do the Big Bang approach. So while we're waiting, we can have a look at this playbook, which is effectively going to run against the whole thing. So I'll just get that copied to clipboard so that when this finishes, should be done any second now, we'll be able to go and have a look. Getting there slowly, so bear with me. Almost there. All right, so what we can do is have a look at also for starters, inside this directory. So we can see there's a bunch of playbooks for RHEL 6, 7, and 8. I'm using RHEL. My laptop is Fedora, so if I was to look at the open source one, you'll see there's a whole bunch. I'll make this a little bit bigger. Run that again, for different operating systems. So Ubuntu, SLES, RHEL, Fedora, etc. Because we're on a RHEL system here, we're obviously only seeing the RHEL ones that are supported by Red Hat. So if we look specifically at RHEL 8, there's the Essential 8, sys, PCI, etc. So let's have a look at the sys playbook. And you can see that if we scroll to the end, there's like 16,000 lines in this file. So there's a whole raft of stuff that it does. And what's good is that every single task is tagged, and this is automatically generated to either fix everything or fix just the problems that are applicable to you in your system. So what we can do is let's run the whole thing. So we can just run Ansible playbook and then specify the Ansible playbook here and then run it, and it'll kick off and run all the hardening tasks against our system. So this takes, for a system that's not been hardened, around 10 minutes to run. For one that already has, it takes a little bit longer. So once this is finished, we can then run another scan, and here's one I prepared earlier that has all of the compliance settings fixed. So whereas before we had a score of 77, we've now got a score of 96. Now, why is it 96 and not 100? So there's a couple of rules that are contradictory. So one of them is to verify the correct file permissions with whatever the RPM package has, and then there's other rules later that go and change file permissions. So I seem to find that that one always needs to be ignored. There's also, I'm using a cloud image that doesn't have varlog audit, and var TMP on a separate partition. If it's on-prem, you can obviously have your partition table to set it up that way. Or as part of your SOE build process, you may wish to create those partitions and copy files in there. Everything else, so again, these are bootloader password. Well, I don't really want to have to put a password in every time we do a reboot. But yeah, effectively, we've got through most of those rules. But you can filter them as well. So we can say only show me the ones that I failed on. So we can get rid of some of those. And then we can only see the failed rules. So the next thing, this might take a little while to continue. So in my other tab here, I'll jump into that same Linux server again. Switch to root. And we want to be able to have a look at is security scanning, CVE scanning. So we can run yum update info. And this should tell us if we've got any packages applied. I'm tipping we won't, because this would have been patched as part of the hardening process. So there aren't any. But if I ran this, for instance, I've probably got patches on my own laptop that I need to do. So we might see that, I haven't patched my laptop in a while. So that's not too bad. I've got 10 security notices. So this is the type of output that you would see. If we want to do a scan, we can jump back into the system and use the same commands I had in the slides to go, and we can download these files to make sure we have the security advisories to scan against. So just grab those. So we can see they're sat in our home directory, and this is the report and the scan file from earlier when we ran a scan. We can then go and kick off the scan. So it's basically running this, and we paste that in, and that's going to create a results file, and it's also going to create a report file to go and have a look at. So this does take a little while. It's a single-threaded process and can take time. So what we'll do is have a look at one I prepared earlier. So this is an example of a server that had still a 99.39% score, but there were, and you can filter on rules that failed and didn't pass. So we can see a bunch of fixes that are security fixes that apply to the system that we're on, whether or not they're important or moderate or whatever. So luckily there's none that are critical, which is good. And this is still running, but once it produces the HTML file, which again is one I prepared earlier, we can see that it's gone and we've got a score of 100, which is great. That shows that our system is up to date. You can show all of the detailed results, and this is probably going to make Firefox very unhappy when I go to do this. You can expand that because it's actually quite a large HTML file. And eventually we'll get it to open, and we'll be able to see a list of all of the fixes that are successfully applied on this test machine that we're using. So that's really the main part of what I wanted to show. Obviously still got the playbook running in the background, and we've got our scan running as well. I do have time obviously for questions or anything that would be handy for me to go into more detail. So please feel free to either come off mute or pop a question in the chat, and I'll be more than happy to try and answer it. All right. No questions. Thanks, Arian. Hopefully someone can be brave and ask a question, help us out. But yeah, well, we'll let this finish, and we should be able to see that this completes. Thanks. And we'll see that everything's done. the slides should be made available, like I said, after this, and I might, if you want to grab a copy of these are exactly the commands that were run to be able to do this as well. All right, so if there's no questions, we'll let this finish, and we should be able to see that it's all done. And this scan's running as well. So what I did notice, and I'll just SSH back into that server again. Let's make this a bit bigger. You can see that when the scan is running, it is a single threaded process, and we can see that it's basically using a lot of one thread on the instance that I'm using, and we've also got the Ansible process running. So because it does take a while, it is good to kind of have this baked into your sort of, gold image or provisioning process and do it early, where you won't have to do it afterwards. And then you can just do a scheduled scan at certain intervals to be able to pick everything up. Thanks, Kev. Appreciate that. So yeah, we should see this finish. And like I said, I think we've got a finished, so which was good. So it checked 707 things. It changed 55 and skipped 238. So I'm not sure exactly how long that took, only a couple of minutes, but it was able to fly through a whole bunch of checks to make sure that all the hardening settings were switched on. So yeah, as I said, if there's any questions, please pop them in the chat. I should keep asking, and I think my colleague Steve and I are in a virtual booth sort of thing after this as well. So if there's any questions or you wanted to run through anything with us, we'd be more than happy to chat to you as part of that. Which I think I'll just check the time is at 10:05 this morning in the time of the conference. I'm based in Australia, so it's like 7 o'clock or something in the evening for me. But once again, thanks everyone for attending, and hopefully that you guys took something useful out of it and can go and harden your systems with Ansible and OpenSCAP. Thanks, Andrew. All right, so we'll probably leave it there, and I'll stop the session now and enjoy the rest of the Runecast conference. And once again, thank you very much for joining the session. Cheers.